graph is where you're going to want to find the relative mins and relative maxes. Okay? So relative minimum means basically where does a graph change directions? Where does it go from what's called increasing to decreasing? And so when you look at this graph, how many different places is there a relative minimum? Anybody? Where is there a point where it changes directions, but it's the lowest point? Yeah, it's just this one point right here, right? And this is the only point that is a minimum, relatively speaking, right? Because it's not a minimum from the whole graph, because there's all of these points to the left of this are lower. But relatively speaking, or within that a little range, that is the lowest point. And it's what's called changing from an increasing to decreasing function. Okay, so this is the point that we want to identify for our relative minimum. And when you guys learn how to, if you guys get to calculus, you can find these points by using calculus. Okay? However, in this or at this level here, we're not going to do that. We're simply going to find the location on our graph. And the way that we're going to do that is, again, use the Math tab. We've already done values and zeros. We've done minimums and maximums with parabolas as well, so it shouldn't be anything new here other than the fact that determining the upper and lower bounds are now going to play a key role. So when you look at this, we do want to find a minimum, so we're going to choose number 3. And it says the lower bound. Okay, what happens if I pick a 0 as my lowest bound? It's going to be at the point at 0, right? It's this lowest. It's going to pick the lowest point between whatever your lower and upper bounds are. So you have to make sure that your lower bound is to the left of your localized minimum. Okay? So let's pick this point right here, and it's always just going to choose the x-coordinate. So what x-coordinate is right here? No, that's the y-coordinate. This x-coordinate is 2. And it's easy. One of the easiest things to do is use a number. If your intercepts, your x-intercepts are constants, are integers, you can usually use those as your left and right boundaries. But if I use either 1 or 2 as my lower bound, so I'm going to use 2. And then my upper bound, I can use anything that falls to the right of this point. So I could now use 9 or 10 or whatever for my upper bound. Remember, our lower and upper bounds are x-coordinates. So anything that's beyond where this point appears to lie, which is between 2 and 3, you can use as your boundary. And so let's say you choose 9 as your upper bound, just to move it on. Okay, you can then identify, it shows you what the minimum point is right here, and so that's your solution. So the relative minimum for this particular case is the point 2.58. I'll probably have you round it to 2 decimals. Okay, and then negative 1.92. And so that's your solution point that is this localized minimum. Okay, meaning it's the minimum within that certain range of values or that certain domain restriction. Okay, so the relative maximum is going to occur where, again, how many different relative maximums do we have? Again, it's just the top of this curve. So we need to figure out that maximum. So F5, the Math tab, we choose maximum. Our lower bound now, does it matter which value we choose for our lower bound? As long as it's to the left of this point. So could we choose the value 1? Yeah. Could we choose 0? Negative 10? Yeah, any number to the left of this. So let's just say 0. So there's my lower bound. And then my upper bound has to be some point to the right of this, but it can't be any further than this point here, right? Because then it'll start giving you this value, whatever that value is. So we need to pick a point that's from here to about here. So we can either pick 2 or 3 as the integer values. Easiest thing to do is to pick an x-intercept that falls between there. We see that that x-intercept is 2. So we can choose that as our upper bound. And it's going to give us that localized maximum, and that's located at the point 1.42 and a y-coordinate of 1.92.